So one of the things I talked about in the first video is that we have to be able to set up the partial fraction decomposition before we can actually go through the process and find those coefficients, those letters on top, the A's and B's. So what we're going to do in this video is we're going to look at the different types of rational expressions that we could be starting with. And remember, I told you that we're only going to be looking at very specific cases. We're only going to be dealing with linear or repeated linear factors in the denominator. So let's look at what that looks like. So when I look at type 1, distinct linear factors, the word distinct means different. So when I look at the denominator here, I have 1, 2, 3 different linear factors, and they're all different, right? Nothing is repeated. Nothing shows up with an exponent of 2, right? Like if I had a 2 right there, that would mean I had 2x plus 5, 2x plus 5 written twice. I don't have that. So when you have distinct linear factors, how you set up your partial fraction decomposition is you make a term for every linear factor. So because I have an x minus 1 in the denominator, there has to be some number over x plus 1. Over x minus 1 in the decomposition. I also had an x minus 5 in the denominator. So there has to be some number over an x minus 5 in the decomposition. And we also had a 2x plus 5 in the decomposition. So there must be some number over 2x plus 5 in the decomposition. And notice that I use different numbers, a, b, c. If I needed to go all the way up to f, I would. It depends on how many different factors you have showing up in that denominator. Now let's look at another example, type 2. Notice that now type 2 has a repeated linear factor. It does have some distinct ones, right? Because there's the x minus 8, which is one thing, and then there's the x plus 1, but that x plus 1 is squared. So you don't have to do this step. I'm just going to write this because I want to emphasize that that is repeated. That is x minus 8 over x plus 1 times x plus 1. Right? The x plus 1 showed up twice because it's squared. So how we handle a repeated linear factor, well, rewind. First, let's just deal with the x minus 8 because we already know how to deal with that. Because x minus 8 shows up in the denominator, there has to be some number over the x minus 8 in the decomposition. Now let's deal with the repeated factor. So how we handle that repeated one is we have a b over x plus 1, but because the x plus 1 showed up twice, we also have a c over x plus 1 squared. So that is how you will handle a repeated linear factor. With type 3, there's repeated linear factors again, but there's no distinct one, right? So like this one doesn't have like the x minus 8 out in the front. Everything in the denominator is the same factor that shows up 4 different times. So how we set that up is we must have an a over the 2x plus 3, but it didn't just show up one time, so we must have a b over the 2x plus 3 squared. It didn't just show up 2 times, so we must have a c over the 2x plus 3 to the third. And it didn't only show up 3 times, it showed up 4 times. So there must be a d over the 2x plus 3 to the fourth. So you repeat it, if you have a linear factor that's repeated, you repeat it in your decomposition, increasing exponents each time until you get up to the exponent that it showed up with. So we wrote it 1, 2, 3, 4 times, increased exponents along the way because it showed up with an exponent of 4. Okay, so this page right here, these 3 things, type 1, type 2, type 3, are very, very, very important. You will not be able to decompose into partial fractions if you cannot just set it up, first of all.